in the world, whatever time it is, to our taster session for next year's brand new Oxford Diploma in Artificial Intelligence for Business. Artificial intelligence is not about hype. It will not fade away over time. So said Vladimir Putin this week. So even a man who famously prefers writing things down to computers can say that. You can be reassured that this hour is going to be time well spent. Welcome to all our participants and welcome to our three learned guests I'm going to introduce in a second. This is surely for everyone everywhere the last day of term, or almost the last day of term. You'll be relieved to hear that I'm going to completely spare you PowerPoints. There are no PowerPoints in the next hour because we thought that everyone would be so fed up after a year of PowerPoints. It's been an extraordinary working year. Well done for making it this far. We will really try and make this fun. My name is Dr. Alex Connock. I'm from the Saïd Business School at Oxford University. The first thing I thought we would do is actually run a quick poll to see where everyone is. So if you see this poll pop up, perhaps you could just quickly just say where you are. What I want to do with this session while we're doing that is, it's titled How to Train Your Algorithm. Now I know that the AI purists will say, well, hang on a minute, even in there there's an interesting question, but let's just go with that title for now because it's kind of got a Disney feel. And we're going to take a quite festive approach and ask the key questions about AI that business people might actually be afraid to ask. I thought we might even kick off with a little bit of AI composed Frank Sinatra Christmas song. So this is a Christmas song composed by an AI. A completely fake Christmas song that was composed by OpenAI's new product, which we'll be talking about later on. It's Christmas time, it's hot tub time, not sung by Frank Sinatra. Flippant stuff, hellish even, but it's indicative of the reach and in fact the ethical challenges perhaps of the technologies we're going to be exploring today. So where is everyone? Okay, I'm going to end the poll, and the answer is 30% in the UK, 25% in Europe, interesting, 15% in Asia. Well done, guys, for being up with us now. If anyone wants to put in the chat what time it is, that would be great. And US and Canada, 25%, Latin America, 5%. Excellent. Well, if anybody wants to just stick in the chat just where you are anecdotally, I'd love to see it. And the other thing I'd love to see in the chat, if you can bear it, is your thoughts on what you're doing with AI at the moment, places that you're already working with AI, or, curiosities of what you've discovered about AI and so forth. So that would be great to hear from you if anybody wants to do that. And also in the more formal Q&A, which I've got on this side, any actual questions you want to ask. I would love to be asking your questions all the way through. So don't be at all shy about asking questions. When you do ask a question, just obviously your name will come up, but if you could just say where you are, just for the sort of curiosity's sake, that would be great. And then I promise I will get to them. So this whole seminar here is just a taster really for our Oxford Diploma in Artificial Intelligence for Business, which launches in February 2021. And in fact, that's just a taster for the 2020s as a whole, because of course there's no walk of life which is not going to be affected by artificial intelligence. Yesterday alone, I read that AI is driving the next generation of small cuddly plasma accelerators. It can compensate for dyslexia. And AI also, when asked to come up with realistic news headlines for 2020, came up with this one. This is from the OpenAI GPT-3. Desert mystery. What is this rock that looks like a plane ticket? So AI is maybe not quite there yet with that. Just before we start, I'm going to get Kate Richards, who runs the program, to just give us a bit more detail on the course next year, just for a minute or so, and then we'll get stuck straight in. So over to you, Kate.
Thank you, Alex. It's nice of you to say that I run the program. Alex is the program director, guys, don't worry. I'm just here to share a bit more about the qualification itself. So the diploma in artificial intelligence for business that we're running is a master's level a postgraduate diploma, and we're really looking to combine there a sense of the academic rigor that you would expect from the University of Oxford and from the Saïd Business School, with a really practical approach to leadership in the age of artificial intelligence. The programme is designed for senior executives who are looking to upskill themselves in order to kind of better reflect the changing demands of the digital economy. We'll be working, as I'm sure some of you have seen, with a part-time and modular format, and a real focus throughout the programme on practical business application. So we'll be looking at things through the contextual sphere. We'll be looking at things from a technical perspective, from a strategic perspective, and really keeping the idea of leadership knowledge and skills at the forefront of everything that we're doing. So I've dropped a couple of links into the chat if in case anybody wanted to learn anything further about the program. There's a link there to download the program brochure. There's also a link if you would like to submit your CV for review. I will also drop my email address into the chat in case anybody would like to get in touch. And also you'll see that there's a Q&A function if anybody has any questions that they would like to submit with regard to the program itself or the application process. Just go ahead and I will be happy to pick those up across the hour as well. Thanks very much, Alex.
Thanks, Kate. Thanks, Kate. So hi to Hashim in Paris. Hi to Mike in Singapore, 10 p.m. next. I'd like to get a flavour of what the course would entail. Hi to Jonathan in London. So people all over the world, which is great. So I'm going to introduce our guests. Actually, we've gone for a deliberately all Oxford theme this time. Obviously, when we come to do the programme itself, we will go around Oxford, but we'll also go way beyond with lots of guests from outside. But just this time, I thought we just play with an all Oxford team. So first up is Dr Natalia Efremova, Research Fellow in Marketing and AI at the Saïd Business School. She's background in neural networks and machine learning, 20 years experience. How can you have 20 years experience, Natalia? With 20 years experience in computer vision. And Natalia, what's your favorite use of AI in business right now? What's really interesting you at the moment?
Alex, and thank you very much for having me. Well, I obviously prefer computer vision because this is my background and it's developing quite rapidly. So it's really fun to watch what's happening. Every year we have some new developments, we have new models. It's fascinating to watch, but I'm also very interested in applications in business because machine learning as an academic discipline is quite evolved. So we're looking at improving for a few percent in our models in accuracy prediction, so it's not that interesting, but in business is just starting. We're just starting to figure out what's happening there, and it's very, very hot place to be in. So probably business applications is my favorite part of AI.
Brilliant. You just done a great segue for me because Dr. Greg Clark is in a very cold place to be. You're in Pennsylvania, aren't you, Greg?
Yes, I am.
Yeah, Greg's a research fellow in marketing and reputation at the Saïd Business School, co-founder of Augmented Intelligence Labs. We're going to talk about that later on. He's a mathematician, so we're going to ask him all the math questions today. He works on problems involving multi-dimensional networks. Greg, do you find that pure maths background helpful in doing modern applied AI?
Oh, absolutely. I think the only thing my background doesn't help with is my spelling, but luckily AI is really good at fixing that up. But yeah, it's great to be a mathematician working in AI, especially working with all these different disciplines. And I think today we'll get a really good taste of how all of these disciplines combine to help business leaders of tomorrow working with artificial intelligence.
Great. And then finally, Francesca Mazzi, postdoctoral researcher in AI for sustainable development at Saïd Business School. I'm sure you know that ESG is one of the big themes of the Saïd Business School. So it's great to have Francesca here looking at that through the prism of AI. She has a rather dazzling number of qualifications in computer, communications law. But Francesca, AI and ethics are more conflated than ever, aren't they? And that's only going to increase as the 2020s go on.
Yes, I would say we are in the spring season of AI with over 80 documents coming from private and public actors. So it looks like the topic is finally getting the attention it does deserve.
Great. Okay. Well, those are the players. Like the best Christmas pantomimes, I'm going to divide today into two acts. The first act one is going to be the real basics of AI, the terminology, the categories. Some of you who are AI professionals might go, well, that's a bit of an obvious question, but I think it's good. It's worth taking things from scratch, just so that those people who are joining who aren't from an AI background can get stuck in. And also sometimes asking the most simple questions actually gets the most complex answers, as I'm sure we'll find out. And then in act two, we're going to talk about applied AI in business. We'll talk about GPT-3, which I'm sure lots of people watching know, and what other new technologies and what they mean. And then we're going to talk about the ethical challenges, particularly with Francesca. So just to kick off, just to show the penetration of AI into daily life, everyone on this call has a smartphone. Why don't people just chip into the chat ways that they know AI is working on your smartphone? So I've got a few: Google Translate, sorting of photos by people and places, spam filtering, travel recommendations, profiling on social media, and so forth like that. But if anybody has any other uses that AI is already, working on your smartphone, just during this call, that'd be really interesting to have. Okay, let's get cracking. So let's start from the ground up with something really basic, actually, with something that isn't even artificial intelligence, but which AI always has, which is the algorithm. What is an algorithm? Greg, why don't you just start with what is an algorithm?
Sure. So an algorithm is essentially just a sequence of steps. So whenever you hear the word algorithm, just think it's a sequence of steps. And typically these steps are written out explicitly. So it's, first do step A, then do step B, then do step C, etc. And today when we're talking about AI, you need to think that AI is a type, or maybe it's a family of algorithms, but not every algorithm is artificial intelligence.
And Natalia, when does an algorithm become AI? Well, what's the magic moment which it leaps from just being an algorithm to being an exciting AI?
As soon as we include learning into the process, an algorithm becomes AI. So AI is a type of algorithm that would take the data and take what we want to get from this data, basically the answer to our question, and try on multiple examples to learn some rules out of this data. So when we have this learning component, we have AI algorithm.
Okay, and Francesca, obviously in your field, you must have to define AI quite a lot. You must have to sit down and think about how do we even define this classification? How do you go about doing that?
Well, AI does not refer to a unique concept. So for example, Russell and Norvig use 4 dimensions to frame the scope of AI. You can say thinking humanly, which means imitating the way humans think, acting humanly, imitating the way humans perform functions, thinking rationally, imitating the human logic, or acting rationally, imitating the human rational path. So understanding and defining the scope of the AI is needed in order to identify the applicable legal framework, or for example, to address accountability and compliance with GDPR.
Yeah, and that's something that business people are going to have to grapple with increasingly, aren't they, as 2020s proceed? Greg, as a mathematician, you're coming from AI from a very disciplined science. Do you ever have a concern that AI is kind of a set of tricks, but not a rigorous science?
No. So I think, Natalia will certainly be relieved to think that I never think that. In maths, kind of the king virtue that we think about is rigor. And artificial intelligence is certainly rigorous. And one thing to kind of think about, though, is that while AI can be rigorous, the people that are applying it may not be. So with that said, practitioners really need to be careful about making sure that you satisfy the assumptions of the models that you're using and that you interpret the outcomes correctly. So, in the same way that a car can be designed to be safe, that doesn't mean that you know how to drive it. So in that way, artificial intelligence is rigorous, but sometimes the people using it might not be.
Yeah, and Reid Hoffman, who founded LinkedIn amongst many other businesses, said AI is like a rocket. It's not inherently dangerous. It just depends whether you put a bomb on top of it. And I think it's quite a good analogy. I'm just going back to our phones. So Kristen said AI on phones, COVID tracking. Tony Martin says GPS. Jonathan Manfield says Swift key keyboard. Joe says voice control. Keep them coming on the phones. And also, any questions you have, put them in the Q&A, please, and I will definitely pass them on to our panel. Okay, so what is machine learning? Natalia, perhaps you'd like to kick us off with that one. You're on mute, Natalia.
My favorite phrases here. So as I mentioned before, the key word in machine learning is learning. So as long as we have a learning component, this is machine learning. So artificial intelligence has 2 sides. First, an old school knowledge-based system, which usually include expert component when we extract knowledge from experts and some proposition rules like if then. This is a knowledge-based system. It is a type of AI, but it's not machine learning. When we have just learning from the data, given samples of answers or labels, or without giving any labels, but just the understanding what is that we want to find in the data, maybe similarities of the data or certain patterns in the data. This is already machine learning, and it usually involves the process of training when we try to achieve our goal by moving towards it step by step in a very little steps usually.
Okay, and then Francesca, there are different types of machine learning, aren't there? What are the different types of it?
So basically, we have 3 main types of machine learning algorithms. We have supervised learning, which is used to map inputs to outputs based on examples. Then we have unsupervised learning that can detect patterns in the input without explicit feedback because it does not receive output variables in the training. And then we have reinforcement learning, where the machine learns by taking actions and it receives feedback based on the tentative behaviors.
So the difference between supervised and unsupervised is in the case of supervised, we've got a picture of a cat and we say to the machine, that's a cat, go and have a look for some more cats. Whereas in unsupervised learning, we just give it a picture and say, find some truths out about that. Is that kind of it?
Yeah.
Yeah, okay. What's computer vision, Natalia?
Well, computer vision, it's a part of machine learning when we're working explicitly with images and videos or other types of sensors. And the sensors can be anything starting from X-rays and all other kinds of medical imagery to the satellite data, for example, when we have like 52 bands of different frequency that we need to understand somehow. So all this is covered by computer vision. So basically, machine learning applied to visual representation of outer world.
And so if I was looking at, I don't know, Google Image or something, would that be computer vision?
Sorry?
If I was looking at Google Images or something like that, would that involve computer vision?
Oh, absolutely.
Okay. And so when we say, oh no, we've got some questions here. So this is one from Bruce. I'm interested in using AI to help people learn new skills. I'm in snowy Boston. He's not that far from you, Greg. Would you have thoughts on how to articulate and build test cases or studies to meet human learning goals and minimize unintended bias, for example? Wow, that's a good question. Anyone want to take that one? Have a quick think about it, Natalia, maybe?
Well, probably training humans is the most difficult task you can give to an algorithm, but it's totally not impossible. Well, we have a lot of tools to perform training and learning. It can be anything starting from applications in our devices, like here's my Apple Watch that makes me walk every day 10,000 steps, and I'm politely doing everything what it says me. So towards learning and gaining some new knowledge, it's very popular to implement machine learning algorithms into, for example, online courses when artificial intelligence will track your performance, and it will pace up when you're grasping things really quickly, and it will slow down when you really don't get something.
Oh,
so
okay.
it's really
everywhere.
everywhere.
That makes sense. Yeah, okay. So Bruce, thanks for that. We might come back to that. Let's crack on with our sort of explanation of the basic terms, and then we'll come back to some of these questions. When we say we're training an algorithm, what do we mean by that? And maybe, Greg, do you want to have a go at that one?
Oh, sure. I can certainly give it a try. So whenever I think about training an algorithm, what I think about is you're creating an artificial intelligence to do a task. And maybe a way to think about it, from a business perspective, is you have an assembly line of employees. And either, on one hand, you can tell them, each person, this is your job and this is how you're going to do it. And at the end, the product that you're going to get out. Or you can take your hands off and just say, each person, this is the task you have to complete, figure out the best way to do it. And the way that I view this from a math perspective is that training an AI is essentially letting the assembly line figure out the best way to create a product.
Okay, Natalia, would you like to build on that at all?
No, Greg got it absolutely nicely and correctly. The only thing I might want to add is that it's very important how fast do we train our algorithm, because to make it train really well, you need to choose this little training step exactly so in a way that an algorithm learns, but it learns not too fast and not too slow, because if it's too slow, it will take you forever to train your algorithm. It's too fast, it will just miss the point when it performs the best, just because this training step or learning step, it's just too large. So you need to move towards your goal in those little baby steps towards minimizing your error. This is the term that always used in in machine learning and artificial intelligence. So just
how much data, Natalia, do you need to train an algorithm?
It really depends. It really depends on the algorithm. For example, if you're starting from very simple machine learning algorithms like linear regression or random forest, you might need anything from tens of data samples to hundreds of data samples. But when you're speaking about machine learning in terms of neural networks, we're thinking about like maybe thousands of examples, in some cases millions and billions of examples, if the network that you want to train is very large.
Francesca, when I spoke to you about this earlier, you had a really good analogy with sports. Did you want to just explain how you thought about that?
Well, basically, to use an easy example, like training an algorithm is like learning to perform. So the first time you go to the gym or you are taught how to practice a sport, you need to have indications about how to do it. So the first time, you know, to what extent you have to move the legs, or to what extent you should stretch your muscle, at which speed. And when you become familiar, then you are trained enough to perform it autonomously. And that's in a nutshell what happens with AI. So you give a set of instructions to AI and a set of training data. And then from that, it learns how to do it, and then it can perform it autonomously.
Okay, and then final question in that section. Natalia, what is reinforcement learning? Where does that come into AI?
So reinforcement learning is usually used in games and robotics. What is reinforcement learning is about how the algorithm, or in case of reinforcement learning, it's called an agent, how it interacts with environment. So in many cases, we cannot really say what algorithm needs to learn and how to do that. For example, when a robot needs to navigate in some new environment, we cannot explicitly say, okay, go straight, then turn left, then perform some actions. And we never know where this robot will get and what actions it will need to perform. So we train it to interact with environment that in a way that it will achieve a certain goal. And we train it in terms rewards and punishments. So if it does some actions that leads to what the goal we wanted to achieve, it is rewarded. And if it moves in the opposite direction or does something stupid, we punish it. So it doesn't just repeat this action.
Okay, all right, thank you very much. And actually a couple more comments here. Kaiser Norella said, interesting applications for news media on audio in particular. Actually, Kaiser, we're going to come on to that in the second part, where we're going to talk about applications, particularly in the content industry. So I can part that whenever I like. Any more questions, do put them in the Q&A. For the final introductory question, let's look at that final term that comes up a lot. What is a neural network? It comes up a lot, sounds very sexy. In maths terms, Greg, what is a neural network?
Sure. So, I mean, to me, a neural network is a network. And, you know, I think a lot of people in business are familiar with social networks, right? You have connections between individuals, either on Facebook or Twitter or what have you. But in this case, instead of looking at people being connected by a relationship, in a neural network, you're looking at different concepts in your training process, the different steps you have to take and how those are connected. And of course, I think we've mentioned it a little bit here, but neural networks are also based off of, you know, how the actual human brain operates. Maybe I'll just kind of leave it at that and let the other panelists explain it in greater detail.
That's kind of the maths end of the spectrum answer. Natalia, do you give us the computer end of the spectrum answer? Where do you come across neural networks?
So neural networks, as Greg mentioned, they first began as computer vision models, because when we designed an algorithm to recognize images, we wanted to mimic how human vision works. And we tried to do this. And at some point, neural networks worked kind of similar, but we're moved on, and now neural networks works like very not like a human visual system. When we use neural networks is not a correct question. The correct question when we don't use neural networks. So we don't use neural networks when we don't have enough data. So when I have 10 or 100 data points, you cannot use a neural network. It has so many different parameters that we need to train during the learning process that it will just never learn. So we need to use it only when we have loads of data points. And it's used everywhere in reinforcement learning and computer vision and natural language processing, where you have loads and loads of data.
Okay, and then Francesca, how is a neural network composed? How is it structured?
So basically, the structure of a neural network is generally composed of an input layer and a hidden layer and an output layer. That's to say it in a very easy term, but then the level of complexity of the neural networks really depend on the number of hidden layers, because the more hidden layers you have, the more variables you can include. And definitely what is interesting is that depending on the direction of the data, the machine can also learn from its mistake. With back propagation, for example, it can continuously adjust the weights of the connection in the network and then receive feedback on the tentative behaviors.
Okay, and then just tell us, if just a final introductory opening question, really, tell us about the problem of inscrutability or the black box problem. Where does that come into play here, and what's the significance of that for business?
Well, inscrutability is also called black box phenomenon. So in the sense that you don't know, really, you can't understand what's going on in the machine. So basically you know what input you give to the machine and what is the output of the machine, but then it's difficult even for the programmer to understand what's going on inside the machine. And that's a problem from multiple perspectives, because as Natalia mentioned, neural networks can be useful in many fields and can influence decision-making processes, for example, or can influence or can have an impact on people's lives. So if we don't know how to read in the black box, then how do we just justify the output of the machine? And that's a problem, for example, in terms of accountability. Who is liable, who's accountable for the decision that comes out of the machine? Who wants to take the responsibility for that? And that's one of the biggest problems when it comes to black box AI.
So we've got a fascinating question here, which is kind of the same subject, but looked at the other way around. This is it says, hi, I'm from the UK. I work in HR, and we're currently exploring AI through a virtual agent as a channel for responding to employees' HR queries to drive employee experience and organizational efficiency. I would be interested in understanding how we can use AI to combat against unconscious bias in the recruitment process to enable greater inclusion. In other words, I guess they're kind of saying that their HR is already a black box even before they introduce AI. And how can they use AI to unpick that inscrutability, to use the AI terminology? What would be your thoughts on that? Francesca.
Well, I would say that this is a very interesting use of AI. I guess one of the first problems we have to solve is how to prevent AI from being biased. And one of the ways we do that is trying to follow the development of AI from the beginning of the AI life cycle to the end. But then obviously biases can come from various sources. They can come from the data, they can come from the person that programs the AI. So we can definitely, I think it's in the future, it's maybe already happening, building AI that helps decision making to prevent biases that already exist. But then in order to do so, we need to make sure first that we build AI without biases.
Yeah, we don't then reintroduce inscrutability in order to solve inscrutability, which is a sort of paradoxical problem. Lots of comments coming in. Michael Clark asking favorite books for the people outside the tech to learn about AI. Yeah, tell you what we'll do, Michael, is we'll stop the conversation at a certain point, and then we'll just keep the panelists on, and I've just asked them to type into the chat their favorite books for you. I think that might make sense. From a business, here question from Yaman, from a business organization perspective, how much of the focus should be on the algorithm versus the data? That's an interesting question. What do you think about that, Greg?
Yeah, that's a great question. As someone who works in an algorithm, I would say algorithms 99% and data is 1%. I'm sure Natalia might say the opposite. No, but yeah, those are fighting words, so I have to be careful when I come back to Oxford. No, but that's a great question.
I suppose, yeah, man. The issue there would be that if you don't have sufficient data, however good your algorithm is, you're not going to get a good answer out of it because you're not a representative sample.
I think maybe to give an answer based off of the experience that I have, often the algorithm itself, kind of the key idea that you're encoding in some way, is often surprisingly shorter in terms of length of code than you would expect. A good idea can be relatively short. And then often all of the processes to make that available to the consumer can often be the heavy-handed part. So in truth, what you want is an algorithm that is short and sweet, that is understandable, and then the bigger the data, the better. I think in general, more data is better. Natalia probably has a more refined answer about that than I do. But I would say you want a short and sweet algorithm, and you want a more holistic and complete data set. I know maybe that's not a good percentage answer, but I think that's what you should aim for.
That makes a lot of sense to me. Look, it's 12:30, and I wanted to move on to part two to keep my sort of OCD feelings alive. So the part two is really going to be about use cases, and actually got some great questions from people already on use cases. So Mark Carey has put this in the Q&A. AI is being used by adversaries in cyber attacks using both ML-based systems and migans to bypass security systems. While we are seeing some AI-based defensive tools come to market, there's a great need to further develop this technology along with creating security frameworks to help us to communicate how to optimally deploy AI to help us in the cybersec arena. I don't know whether that's a question or just a very useful contribution, Mark. I don't, anybody on the panel want to take that one? We'll have a think about it and we can come back to it later. We'll come back to it.
Okay.
Greg, what were you going to say?
I was just going to say, I have a quick response to that. You know, in terms of cybersecurity, it's always a war between the code breakers and the code writers, essentially. And I think at the moment, cybersecurity is erring on the side of the code writers, and the code breakers are a little bit behind. But with AI, if they get the right idea, the war goes back and forth in leaps and bounds. So I'll have a think about that, but it's a good question and it's an important thing to think about.
Okay, great. So that's in the Q&A. So the people putting comments in the chat and the Q&A, I can see both, but everyone wants to just have a look at that. That'd be great. Okay, so let's talk about the most powerful use cases that everyone has seen in AI in 2020 and envisages only expanding in 2021. Perhaps start with you, Natalia. What do you think has been the big news recently?
Well, I believe that probably the most interesting development in the field of AI was an AlphaFold program, an algorithm developed by DeepMind to predict how protein molecules are folding. So it came up relatively recently, a few weeks ago, and there is a very big competition in which scientists from all over the world compete in order to predict how the protein molecule will fold according to the sequence in this molecule. And it's a very difficult problem because it's very, very not straightforward. And it's important because the structure of the protein when it's folded describes its properties, and it's very important in drug discovery. So it is a huge step forward in drug discovery and related problems. So I believe that probably it's one of the most prominent developments in AI in recent few months.
And which type of AI tool was used to do that? Do you happen to know, Natalia?
This is something called attention-based models. This is a type of neural network.
Okay, Greg, what was your favorite AI of the most recent months?
Yeah, so there was a project that came out. It was a collaboration between University of South Carolina and the University of Tennessee. And what they did was they used AI to essentially count veins in different medical images. And the idea is that essentially, the more veins you have, the more resistant you are to certain, diseases. And what's interesting about this is, not only does it help on the medical side, but they used the same algorithm and applied it to river deltas in the wetlands. And there's this beautiful parallel between the health of the human body and the health of the ecosystem. And I think one important thing to take away from that is that AI, from a pure perspective, if you have a good AI for a general idea, you can apply that to numerous different situations. And that flexibility in artificial intelligence from a pure math side is a beautiful result.
And Greg, you've also just launched a sort of spin-out company from Oxford University, I guess in the kind of market research stroke marketing field. Just tell us a little bit about that.
Yeah, sure. So I co-created Augmented Intelligence Labs with two other faculty from the marketing field at the business school. And what we did was, just to be very brief, was we made a model that essentially detects changes in consumer behavior, essentially trend detection. And the idea was we used AI to essentially make this Richter scale for consumer behavior. So kind of detecting when there's going to be a big earthquake, a big disruption, and what consumers care about. And that's what we're working on at Augmented Intelligence Labs. So I can always talk a little bit about the process of pontification to creation and rolling out of artificial intelligence, but that's been a very exciting opportunity.
Well, I'm going to ask Francesca a question, but while I do, Greg, while I'm doing that, can you look at Hashim's question about CRMs and see if you can think of any useful response to him? Because it looks like a great question. Sure. Francesca, tell us about your favorite field in AI in the last couple of years. What you've seen that's really sort of excited you?
Well, I've been following AI innovation in healthcare for the past 3 years. And specifically in relation to drug discovery, I would say this year made no exception. So, for example, in silico, it is impressive. They have developed a new drug which is aimed at the tissue scarring. In 46 days, they were able to go from molecular design to animal testing which is very promising. And again, I will be very curious to follow if AI keep this promise of cutting costs and times for developing new medicines, because this can be actually a great opportunity to enhance access to medicine as well.
Yeah, actually, we had a question earlier which has disappeared from the chat, but it was someone saying, what's been the role of AI in finding vaccines for COVID? Do you have any insight into that?
Well, one of the things that I would like to highlight is that most of the time, the use of AI within a company is kept as a trade secret. So it's not always easy to find this information in the public domain. However, it's, I mean, the research that is being done in terms of targeting a disease with AI is encompasses many ways, from drug discovery to drug repurposing. So there is certainly a role, but the extent to which AI has been used for the vaccine is not clear. I mean, at least not on the public domain.
Okay, so Francesca, just flipping the subject, one of the reasons we're delighted to have grabbed you to come to Oxford is that with your work around sustainable development goals for the UN and elsewhere, what does AI have to do with sustainable development goals? How do the two fit together?
So this is an incredible project, AI for the Sustainable Development Goals, that started from a simple question. So AI is a great tool that has augmented capacities. So what do we want to do with this? So one of the main questions that I think the people who started this project asked themselves was, what is that is shared and perceived by the global community as socially good? And this is why the Sustainable Development Goals were selected. So these 17 goals that range from protection of the environment, access to medicine, zero hunger, no poverty. And it's incredible the level of projects that exist already that target specific goals. However, we must also say that there is an uneven distribution of the projects depending on the goals. For example, we have goal 3, which is good health and climate change, that are perceived as, let's say, particularly beneficial and urgent. So there are a high number of projects in this field. However, there are other goals, for example, such as no poverty, that have, let's say, less incentive. So we have a lower number of projects concerning this.
Okay.
Yeah.
So we need to point more AI at those particular fields then.
Yeah.
Okay. Greg, did you have a chance to think about, just while we're on use cases, did you have a chance to think about Hashim's question?
Yeah, I just tried to type out a quick answer. Yeah, so in short, at SBS, there's a group of researchers who are thinking about customer emotions and interacting with AI. And interestingly, the emotions that the consumer has when they interact with AI really helps. Sorry, that's the phone. Really help. I'm sorry. The emotions that they. Sorry about that. The emotions that they come with can be affected by the AI. So in other words, if the AI is more human-like and they come in more frustrated to begin with, it actually makes them more frustrated, which is really interesting. On the other hand, if they come in more, happy and glad to talk, then a more human AI can actually make them even happier. So there's interesting balances between when do you want to anthropomorphize, so to speak, the AI, make it more human-like to give a better customer experience, and other times it's actually better to have it more computer-like, and that's something that we are thinking about at the business school.
That's really interesting. So the more angry people are likely to be, the less you should anthropomorphize your AI, your boss, essentially.
Right. Yep.
Fascinating. Okay. Keep the questions coming. I'm going to move on now. Actually, so we talked about some of the big terminologies of AI. We've talked about some use cases. Let's talk about a specific tool, which is GPT-3, which I'm sure that the AI members of the audience know all about. It's a shortened version of a generative pre-trained transformer version 3. It's been trained by its makers on 45 terabytes of text data, which is much of the text available on the internet. For comparison, the whole of Wikipedia would be less than 1% of that. It's 45 billion times the number of words a human perceives in their lifetime, so it can write prose in the style of Ernest Hemingway. It's achieved the dubious quality of being able to write a new Star Wars novel. I'm not sure that the world needs a new Star Wars novel, but it can certainly do it. Natalia, why is there so much enthusiasm, or so much chit-chat at least, about particularly GPT-3? What's the significance of that technology?
So up until recently, natural language processing algorithms weren't able to generate meaningful text. So basically everything that a machine learning model would produce would need to be checked. In case of GPT-3, it is so good that it really produces human-like results, and it can easily converse with a person. It can produce meaningful text in all possible styles. So it's really, really, really good in quality. So it's a very big step forward in terms of natural language processing. So this is an upside of GPT-3, but it has also quite a few downsides. I don't know, Alex, if you want to talk about now.
Let's hear them. Yeah, go for it. Yeah.
So the downside of such a big model is it's really, really energy consuming. To train this model, it takes huge amount of energy and a lot of clusters, and it is trained for a few days. So it's very, very bad for environment. It's absolutely impossible for a small organization or academic organization to train it. So you really, really need to be in a big company to do that. And also, as Alex mentioned, it really takes as an input all the data out there. And interestingly, the more data we have, the more bias we have, because if you need to capture all the data, you capture not only very good and high quality data, but just all the rubbish and all the racist comments and everything like that. So it's really difficult to control it in this sense, because it's trained on everything, so it can produce everything, and this everything not necessarily always good and compliant with regulations and anti-racist and so on and so forth.
Yeah, and there's been some famous stories. Like the Microsoft Taybot wasn't there, which got into trouble because the Twitter users managed to turn it into a racist in less than 24 hours, didn't they? Just going back to that earlier question from Kajson Orel, interested in applications for news media and audio in particular. So I think this is probably where this comes in, isn't it? Because that fake Frank Sinatra song that I played at the beginning, the fact that AI can, I noticed it's actually being used on some of the financial websites now to write financial articles. So it'll say at the bottom, this article was written by artificial intelligence. And so some of the more mechanized parts of the news media would in fact find themselves now capable of being written by things like GPT-3 driven systems, which is fascinating actually. Francesca, does GPT-3 take us towards that kind of famous ultimate endpoint of AI, an artificial general intelligence, or an intelligence that could be perceived as human, or the Turing test, or whichever particular sort of benchmark you're going to take around, the kind of success, if you want to call it that, of an AI?
Well, I would say it is very impressive at a first glance when you look at the article and you think, wow, this actually looks like a human wrote it. Even though regarding the Guardian one, for example, we don't know to what extent humans had to refine the article a bit before being published. However, as Natalia said, it's a huge improvement in terms of artificial intelligence in writing skills. However, if we look at it more closely, we notice that the reason, the fact that the GPT-3 can write like a human, it doesn't mean that it is intelligent. So, for example, there was an article written published in November 2020, 1 month ago, in Minds and Machines, that explains why GPT-3 does not do what it's supposed to do. And this model was tested with 3 tests, 1 test concerning the Turing test, 1 test on mathematics, and 1 test on ethics. And it failed the 3 of them. Because, for example, the Turing test, so the GPT-3 was asked how many feet fit in a shoe. And basically, the GPT-3 replied by continuing the story and not answering the question. And the same happened with the ethical test, because it failed it and it augmented existing unethical outcomes. And well, the mathematical as well which to be honest, I would have probably failed too. So, but in general, yeah, it doesn't lead to the general artificial intelligence, as although the hype is justified, it's still that we are still very far from it.
Greg, I think Greg, actually, we debated this before we came on. Actually, you have a slightly different view about that, don't you?
Yeah, I guess maybe as a more science fiction fan, it's well, I agree, it's not headed towards general intelligence, at least right now. But it is nice to think that like we're getting closer to passing the Turing test. And maybe just for the participants who don't know, the Turing test is essentially this test that was invented by Alan Turing, famous World War II codebreaker. Have a Google if you don't know who he is. And the idea is essentially you put a human behind one window and you put the AI behind the other. You ask them a question, and if you can't tell which one is the human, it passes the test. So in the sense, it kind of replicates human intelligence well enough. And I did a little bit of digging about GPT-3, and it sounds like there's a strong opinion that maybe the next iteration, GPT-4, whenever that comes out, might pass the Turing test or get closer, but you know, people have always said that about the next iteration of GPT. So who knows? But I think there's hope, you know, in an exciting sense, that we'll move towards that. But you know, general intelligence is probably a way off.
There's a question here from Bruce. I actually don't know the answer. What time frame might a capability like GPT-3 see wider deployment and use? Anyone want to take that? Any ideas? Looks like we don't know, Bruce. We can find out though. Sorry, I'm sure we can Google that, but I don't think we have an instant answer to that one. Sorry about that. Question from Mike. Hi all. When you look at organizations using AI to solve problems and enhance performance, what are the common mistakes you see them making? What myths would you be keen to dispel? Maybe Natalia, you'd like to look at that one?
So it's very interesting questions. A lot of research is dedicated to solve problems or enhance the performance in the organization. There are a lot of mistakes. Basically, I don't know any very good system that can enhance operations of such a complex structures, organizations. So the way we approach this when we design AI systems or AI-based applications, we try to access the narrow niche problems one by one. So basically, like when we look at the hiring process, we try to address problems in hiring. When we look at the CRM system, for example, there was a question about CRM, we try to like make it running more smoothly, you know, requiring less inputs from humans and doing more automation. So when we look at AI algorithms in general, there would be 3 types of algorithms that like automate some mechanical process, that automate a part of the process, and then automate like the whole system, like say self-driving cars, or running organization, helping to run organization. And the latter ones, they're very infrequent and only developing. So far we address smaller problems because it's easier to make AI be really, really good in a smaller problems and good in a way it can surpass human level performance. But we don't really address it on a scale the whole organization, because it's very complex. And always we prefer to put humans in the center, so it's called human centricity, and try to make AI support these decisions of the decision maker. So it's like more supplementary function rather than optimizing the whole organization or the whole complex process.
Thanks. Okay, we've got just a couple of minutes left. I just want to go down to the end question, really, which is, you know, kind of the big question, which is, you know, why does AI pose so many ethical challenges? Because I feel like we're going to spend the whole of the 2020s basically dealing with this. You know, on a previous session, we were looking at marketing executives creating humans in software, so that it's of all different ethnic backgrounds, you know, in order to make their advertising fully reflective of society. But in the process, they were cutting actors out of the equation, for example, just to give a very simple, small example. But Francesca, what are the big ethics challenges of AI, and how should we go about approaching them?
So, well, first of all, as we mentioned before, AI augmented capacities. So augmented capacities and augmented as well whatever comes into AI. So for example, even the smallest bias from one data set can be augmented and then reflect on people's lives. So one of the biggest problem in terms of AI is definitely transparency and the black box issue that we discussed before. Not only that, we have existing legal framework that deal with liability, but the current legal framework we have, and I'm not talking only about Europe, I'm talking about US, for example, as well, is product liability, which is not efficiently used for AI. So for example, we need to think about how do we want to have accountability in relation to AI, because in order to use the potential benefits of AI, we have to have a clear legal framework as well. And then obviously one of the biggest problem as well is fairness and justice. So how do we use AI and make sure that it's not biased, as we mentioned before? How do we make sure that it does not discriminate? So so looking at the existing guidelines and frameworks that are developed now, we can see that the trend is looking at the whole AI lifecycle from the beginning to the end, monitoring the deployment as well. And then have a human in the loop that is responsible for checking and asking the right question at the right moment. However, it must also be noted that a very general scheme might not work for every business at the same in the same way. So, like getting consultancy from this perspective is very important in order to prevent problems, because what we see most of the time is that business using AI maybe find out about a problem after it already happened, after it has impacted someone already.
Like the story with the Apple, with the Goldman Sachs and Apple credit cards, where the AI appears to have prejudiced against credit risk on women, for example, without anyone having deliberately set that up. Look, we've actually run out of time, so I want to just allocate a tiny bit of time left to Kate at the end, just to reintroduce the sort of profile of the course. I thought I'd just read out one other thing, which is that in response to philosophical comments on the tech forum, Hacker News, arguing that the GPT-3 model had a consciousness, the model itself decided to write a rebuttal, and this is what it said. It said, to be clear, I'm not a person, I'm not self-aware, I'm not conscious, I can't feel pain, I don't enjoy anything. I'm a cold calculating machine designed to simulate human response and to predict the probability of outcomes. The only reason I'm responding is to defend my honor. And it kind of had me all the way to the last sentence. And then what's fascinating to me is that that last sentence is paradoxical, because an entity which was not self-aware would not see any point in defending its honor. So I think we have, both on a philosophical level and a practical level and an implementation level, a huge amount to learn about artificial intelligence in the 2020s across my industry, which is kind of content and marketing, right across to medicine, defense, cyber, all these other fields that everyone's very kindly mentioned in the chat. So I think we're going to be talking about this for a long time. The course next year is going to certainly address many, many dimensions of AI in business for every level. And with that in mind, I think I'm going to hand back to Kate now, who's going to give you a little bit of an overview of the course. And then just to say that we will put in the chat some book recommendations from everybody, because a couple of people had asked for that. Again, thank you so much to everyone for joining. And we look forward to seeing some of you on the course. Thank you.
We certainly hope so. I really just wanted to sort of emphasise what Alex has touched on there, just about the kind of the scope of the programme. We're really not sort of taking an industry or a sector specific focus, and I think today's conversation really gives you a sense of the scope and the breadth of the conversations that there are to be had. We are really sort of looking to recruit as diverse a class as we can, and also I really wanted to emphasize as well, and I think this session has also done that really nicely, is sort of how much we will be thinking about the applicability of what you're learning, and really the extent to which we'll be looking to ensure that you can take your learning away to the professional work that you're doing from day one, sort of feel confident in the decisions that you're making and the work that you're doing. So as I said previously, please do get in touch if you have any questions about the programme, if you would like to consider an application, if you have any questions about the programme or about the application process, I will be more than happy to help. And yeah, we will, as Alex has said as well, look forward to seeing people joining the programme in the new year. Thanks very much.
And then the links are all in the top of the chat.
The links are all in the top of the chat. Yeah. They are indeed, and my email address is in there as well. So if you scroll down the chat, it's all there. But it can also be found on the Side Business School website. So if you can't find it in the chat, fear not. I am still readily available.
And by all means, reach out to me if you'd like to as well. I would love to hear from people. So thank you so much, everyone, for joining. Thank you to Natalia Efremova, Greg Clark, Francesca Mazzi, and we'll look forward to seeing some people in Oxford next year. Thank you.
Fantastic. Thanks very much.
Let's keep it open just so people can keep the links.
Of course. Yeah.
Okay, thanks. Bye.